Okay, welcome back. How's everybody doing? Can you guys hear me? Give me a thumbs up.
Sure.
Okay, good. All right. So, okay. All right. So the questions, and I will go back to the whiteboard, and hopefully the whiteboard is going to be kind to me. Okay. And okay. So yeah, in fact, so you said, is it possible to go over the practices sometimes together? And that's exactly, I don't know if you were in the last class or not, but I started to do that with the first one. And in fact, I would say, something like, half of our lecture ends up being kind of, playing around with the practice problems to make sure that people are on board and their questions get answered. That being said, um, you know, if we get started with a class and there's something that you want to talk about that was like one of the questions, we can either do that kind of quickly at the beginning or at the end, and I'll send out information on office hours, and obviously those are going to be Zoom meetings, and um, then you can come to office hours and we can talk about it. So there's, yeah, there's a lot of good chances to talk about the practice. Okay, so last time together, we talked about demand, and specifically, we said that demand is a relationship between price and quantity demanded, and that obeys the law of demand. And um, we said that the law of demand just simply said there is an inverse relationship between price and quantity demanded. So, and then we talked about that there are 3 ways to represent demand, and the 3 ways that we gave is, we said you can have a demand schedule, which is a tabular representation. You can have a demand curve, which is graphical, and you could also have an algebraic representation, which is an equation. And we said mostly in this class we'll be focusing on this graphical representation. And we talked a little bit about the idea that for the different representations, there's a different amount of information available for the purpose of doing an analysis of what's going on in the situation. So the tabular one we said was the demand schedule, and you'll see some examples of this in your book, but I'll show you guys really quickly. We talked about it just a little bit. Um, and maybe it's just easier here. So we'll have one column for price and another column for quantity, and so well, no, maybe I can make it look a little bit better. Let's see. Okay, so we'll do it like this. So what I'm trying to capture here, but because the text and everything is a little bit different, is a little T like this one where we have price, and over here we have quantity. Okay. So we were talking about bottles of water last time. So maybe we'd start out at a price of 0 and say if the price was 0, then we would have some maximum quantity of water that would be demanded, maybe 100 bottles, right? And at a price of 25 cents, then maybe we'd have something like 10 bottles demanded. And again, it'd be important for us to talk about our period of time. Maybe we're talking about a day or a week. And then at 50 cents a bottle, we'd have maybe 5 bottles, and at $1 a bottle, maybe we would have something like 3 bottles. So notice that we have an inverse relationship here that's captured in the table, but we don't really have a way of answering the question because it's not written down there, right? How many bottles of water would be demanded at 75 cents? Well, we don't know. I mean, it's reasonable, and it's often done this way, that they call it linear interpolation, right? Well, I know 75 cents is halfway between 50 cents and $1, and halfway between 5 and 3. If I take 5 and 3 and divide them by 2, I'd get 4. So it's a reasonable guess to say that, at 75 cents, we'd have 4 bottles of water being demanded, but we don't really know, right? I mean, the consumers, you know, choice there just isn't listed in our table. And that's why I say, like, a table, has partial information in it. A demand schedule has partial information in it. And if we look at the graphical representation, then we have more information, but it also depends upon, again, like what the range of our graph is, right? It turns out, like, in practice, that usually if you're using this type of stuff in business, you have a range of prices for which your product has been offered in the past, and based on that, you have a good idea of what's going on with demand within that range of previously offered prices. So, for example, if I draw a little graph over here, and I have, let's say, a segment of a demand curve, and I know that previously, and here's, the price measured in dollars. And down here, we have the quantity. So I know if I've seen, right, based on the data, from my company records, that I've seen a price of, let's say, $1. And I know that at that price of $1, and it's a little bit difficult with the tools we have available uh, to draw this, but I'll say we're talking about this point right here, right? If I know that I've seen in the past that there were 3 bottles of water that were purchased at that price, and I know um, let's see here. And I know I've seen this other price at 50 cents, and I've seen 5 bottles of water purchased at that price. And then let's just suppose, there are lots of little dots in here, they're increments. I've seen all this. And then, I have pretty good information about what's happening on this part of the graph. I've seen that. But at maybe prices higher at $2 or at prices lower than what I've offered, I don't really know what's going on, right? There's incomplete information. And the other way of doing it, but it's also worth bearing in mind, it's not like we escape the problem. But if I talk about the demand equation, the algebraic representation, right? And I say something like, well, I have this equation that relates price to quantity demanded. I'll say it's 100 minus 2 Q, right? So that's just an example. Well, I could graph that equation and I would have an entire range. I would only be interested in positive prices. So we rarely in economics do we entertain negative prices. Though if you guys think about it, then you realize that negative prices aren't really a bad idea in all situations. When you're talking about something like what are people willing to pay for garbage, right? Well, they're willing to pay something to have people take the garbage away. So you could represent that, and a lot of people have in the past, as a negative price, right? So the point is that we could graph this whole equation, but normally you get these kinds of equations, demand equations, from statistics, from data that's supplied by the corporation, and you estimate it. Well, again, you still have kind of the same problem, right? You can estimate an equation, and then you can look at values outside the range of your data, but in truth, the information that you used to estimate it is just upon that data that comes from the stuff that you've seen. So kind of what's going on outside that range is the statistical algorithm's best estimate of what would happen for the area that you haven't seen, right? The higher prices or lower prices than what you have data for. Nevertheless, if you have an algebraic representation, it potentially contains more information about what's going on with demand than either the graphical or the tabular version. So that's really the difference. So let's go ahead and we'll go back to Ignitium, and let's make sure I have the chat available. And so you'll notice, and like I told you guys before, this first exercise is really, I'm gonna try to, okay, so I should be able to see if you guys type something in the chat now. So these first couple of questions, I think you guys can all play around with, and that's fine. We want to talk about a couple things with respect to demand, but let's just focus in on just these exercises for a second. So notice that, and this is one of the things that sometimes confuses students. We have these general equations, and we don't necessarily, and let's just take a look for a minute, because I don't remember. If I go under practice and I look under the demand practice. Okay, yeah, here. So notice that instead of using the variable y, which is generally for whatever you're just graphing in the y dimension, we use p with a little b. And so what that's supposed to stand for is the price that the buyer would be willing to pay. And q with little b is the quantity that the buyer would purchase. Okay. So, and I think I mentioned this to you guys last time. Really, demand is like a wish list. But one of the common places of confusion, I mean, what happens in all sort of like applied math is the math that you guys are going to see in this class is math that you guys have been seeing since you were probably, my daughter is in 8th grade right now, and my youngest daughter, so she's 13, she just turned 13, and she's taking algebra. So, algebra 1, but I'm pretty sure that everything that is in this class, I'm trying to think of exceptions, but I don't think there are few, if there are any exceptions, is stuff that she's all going to learn. this year when she's in 8th grade. So you guys have been doing this stuff for a while, but one of the things that confuses people is that, in applied mathematics settings, in economics, or if you're in engineering or statistics or something like that, then, we use labels for the variables that are convenient. So since we're going to graph price on the y-axis, we'll just use something that reminds us that price is in the y dimension. And since we're going to do quantity in the x dimension, we'll just use some variable label that reminds us of what we're talking about, that we're talking about quantity in that dimension. But apart from that, everything else that you're going to see is stuff that you guys have, already seen, but maybe under different labels, just because you were used to using y and x for the vertical and the horizontal axes. So this first question just says, okay, let's take a look at equation 2, and what's the vertical intercept? And so I'll ask you guys now. We'll try to go through a couple of these really quickly. So if you want to volunteer to answer in the chat, just say volunteer. Okay. So who wants to volunteer to answer this question number 3? Okay. Are you guys? Oh, okay. Quan volunteers. I didn't know if you guys were being shy or not. Okay. Okay, Quan, do you have your mic?
Yeah, I do.
Okay, okay, good. So without telling us the answer, right? And I want to show you guys something, right? So these are all labeled as demand and supply. In most cases, they are because the equation is going to represent demand and supply. So there's no, I didn't change the labels on the graphs because from what they would typically be. But I want to show you something. So equation number 1 is that one, and I can get rid of it by clicking on the key at the top. Right? So I don't know if, it needs to be let go of or not, but if you wanted to, you could do that. And I can also get rid of this one if I want to. But because we're talking about equation 2, I don't know why I would want to do that. So I got rid of it. I'll now they're both away, and there's the equilibrium point where they were going to cross, right? And I can get rid of that one too. But um, if you wanted me to mouse over the answer to this question, can you tell me where I should put my mouse? Should it be the blue line or the red line? And
Um, would it be where they intersect?
okay, so it says, what's the vertical intercept of equation 2, right? So this point where they cross is a crossing point, right?
Hmm.
So it's not the crossing point. Um, so do you have any other suggestions or?
Vertical intercept. Um, so it's not like 59. It
Yeah, that's where they cross, right?
okay. I'm not quite sure. I thought it was that.
Okay, okay. Does anybody else want to give it a shot? Um, so Spencer, are you there?
Can you hear me?
Yeah, I can hear you. So should I be on the red line or the blue line?
Equation 2 has a positive slope, so a red line.
The red line. Okay, so I'm on the red line. And where should I go on the red line?
You should go to where y or where x equals 0, because that's usually the vertical
Yeah,
intercept.
right. So, and again, so you probably remember 8th or ninth grade or whatever, right?
Oh yeah, I'm a physics major, so we use this like a lot.
Okay, yeah, right. And I don't know if you guys in your discipline do the same thing. I'm sure you do. You give like you're using the same math that we've all been using, but you just give special labels to things, right? If you're talking about,
Oh
the
yeah,
permeativity of free space, right? It's
it's just bigger words for the same thing.
yeah. So yeah, so 0, and then I go up to the red line and I see 31. And I mean, you guys aren't supposed to have to pay attention to the equations themselves, but you can also notice that it's that first term there. So yeah, and then, so is that what you were going to say, Spencer? It's 31,
Yeah.
and let's submit. And wow, we get feedback, 31. Yay. Good job, Spencer. Okay.
Woo.
Woo, the crowd goes wild. So a lot of this, it may be a little trip down memory lane for you guys. It depends on what your major is and what kind of language. Even if you've been doing something in math, maybe the language is a little bit different. I will tell you guys this: it's rare, but um, most students that struggle in econ, it's because the math and the graphing, it's just stuff that they don't doesn't sit well with them. But I have occasionally some students that are really good in math, and you know, the physics people and whatever can understand this too. You might have a friend that's a great, you know, mathematician, a great math major, but for some reason, you know, they get into physics, there's lots of math, and they just melt down, and it's just because, you know, the labeling and the language, and you know, they find confusing. So anyway, so we'll move on to the next question. So consider this equation, blah blah blah. Again, what's the vertical intercept of the resulting graph? Does anyone want to volunteer for this one? This one's maybe a little bit easier even still.
I volunteer.
Who is it?
Don.
Dawn. Okay. Yeah, if you're gonna volunteer, just type in the chat so then I can see your name.
Oh, okay.
Okay. But that okay. So Dawn. So again, if I look at this, where should I go? I'm on the blue line because there's only one.
Yeah. You go on when x equals 0 because it's the vertical intercept.
Yeah. So x equals 0, and then it
Mhm.
gives me 110,
Mm-hmm.
and then I put in 110 and submit, and I get the feedback 110. So, Dawn, good job.
Thank you.
You're welcome. Okay. Okay, so let's look at this next one. Ooh, okay. So consider this next equation, blah, blah, blah. What's the slope of the graph? So anybody want to give me a volunteer for that one? Okay, so I think Anthony volunteered. Anthony?
Yeah.
Okay, so what do you come up with?
So it would be -2, right?
So Anthony says -2. Now, I also want to point out to you guys, and that's right, Anthony. I'm you know, very confident that your answer is right, unless there's something goofed up on Ignithium, which, you know, I mean, I don't think there is, but it should be fine. But you guys might remember that there is a definition of slope, right? So slope equals, and this is what you guys should know, rise over run, right? And so generally, right, what we would do is the slope of an equation like this, which is a linear equation, it's constant, and so it's not going to change, right? And so we could look at these little bubbles and we say, oh, okay, we have notice I'm on demand is equal to 12.5 units, right? So the quantity demand is 12.5 units at a price of 62. And then if I raise it to 63, it drops to 12 units. Well, so here the run is equal to the change, right? And so I went from 63 to 62. Oh, actually, I have to take this back. Blah. Because the run is what's going on in the quantity dimension. So I take it back. And so maybe actually what we want to do is look for, there's the demand is 13 units at $61, right? And then there's the demand is 12 units. So that's a 1 unit change. So this is going to make our lives easier, because in this equation, we'll be making sure that just the run is equal to 1. So the run, we said we were going from 13 units, or from 12 to 13 units, right? And it's kind of important. So notice here, so that means the run is equal to 13 minus 12. So the run is equal to 1, right? Which is what we wanted to keep our lives easy. So, so let me get back there. So we went from 61 to 63. So this is important, and you'll see there are a couple different places in this class where we do calculations, and we have to be careful, right, that we don't mix things up. So the rise, or the change in the vertical dimension, At 13, we had $61, right? And at 12, we had $63. So that was a change in the vertical dimension of -2, right? 63 minus 61.
So,
So was there a question?
sorry, I was gonna say that for this problem, I
Mhm.
mean the equation kind of give you the slope too, so all you have to do is just write it.
Yeah, but you know what I'm trying to do is to make the point that we really don't need to look at the equations. The data on the graphs will give us the information. So you're right. I mean, this is like a classic y equals mx plus b, where m is the slope and b is the vertical intercept. I know that. But for people that are a little bit uncomfortable with the algebra, I just want to make sure that they understand that they just need to know that the concept of slope is the slope of the line. And if they measure it carefully, they'll get the correct answer, even if they don't remember any of the details about how to interpret the equations. So anyway, it doesn't mean you don't have to do a little bit of calculation. It just means that your algebraic sophistication can be very modest, and you can still get the right answer. So now, based on our calculation, we know slope is rise over run, and that's, we picked, conveniently -2/1. We made sure that our run was just a positive number, and it was 1. So we can put in -2, and we get our feedback -2. We're good. So that was Anthony, right? So I'll say, yay, Anthony. You got the right answer. So yeah, so when I go through these things kind of carefully, there will be a lot of people who say, I can just look at this and look at that. But one of the things that I want to kind of point out to you that honestly is a key to success in this class is looking carefully at the graphs, because you'll see as we just get a little bit deeper into the class, the algebra, if we try to do everything algebraically, the algebra kind of explodes on us. But the thing that stays very simple and straightforward is looking at the graphs and picking points and looking at how those points are labeled. If you do that, then obviously you have to kind of go along and look at the points carefully and things like that, but the answer will be immediate, with just a few minor calculations. That's generally the way that it's easiest. Not like in these very simple cases, it might be easier to look at the equation. There's no doubt about that. Okay, so let's look at number 6 quickly. This is a little bit different. Do we have a volunteer?
Right here, sir.
Okay. Do you want to put in? Is it Emmett or is it somebody else? You want to just say
all right.
volunteer in the chat, and that way I know who I'm talking to. Okay, Lawrence. Okay. So for this one, obviously there's just one line here, and it's asking about the horizontal intercept. So where should I look?
All right. So first you look at so on the price, right? You go to like the 0 all the way
Okay.
here, and then you look to the right.
Yeah,
Just,
so it's this little point over here, right? I just go
yeah.
down, and I don't know if you guys have gotten the idea of the language here yet, but the point is that, the price is the vertical dimension, so the vertical intercept is just
Yeah.
where the line hits the vertical axis, and the horizontal intercept is just the horizontal intercept, so that's just where the line hits the horizontal axis. And it says it's 55.5 units. Is that what you would agree with?
Yeah.
Okay, so let's see. 55.5, submit. And look, and this is what's going to happen a lot of times in Ignithium. And so it'll give you the feedback, but a lot of times it won't be 55.5. It'll be like 111 divided by 2. Now, this might be a little bit confusing to you guys, and that's fine. What Ignithium is doing, and some of the ones that you'll see later, are a big, long string of calculations. But if you take those calculations and you put them in a calculator, and you'll see a little bit later when we do the homework, there's a calculator that's available to you where you can do that to kind of check your work. But you could also just keep a little calculator with you. You have your phone with you. You'll get the decimal equivalent of whatever comes out of those calculations. And Ignithium, in most cases, expects 2-digit precision. So, we're talking about dollars and cents. And if you get to 2-digit precision, if you're, plus or minus a penny, then it'll count it. If you're off more than that, then it won't. And so it is looking for the decimal answer. And that's worth saying. I'll put it in the chat so everybody knows. Ignithium is looking for a decimal answer. Okay. So I've had students in the past, and honestly, you do this at your own peril. I know it's looking for a decimal answer. I've had students put in an answer that is not calculated, meaning like 111 divided by 2 is not a calculated answer. That's just, like an equation or fraction yet to be put in decimal form. And they've claimed to me that Ignithium has scored them correctly sometimes. My advice to you is if that happened, it was an anomaly. And I wouldn't recommend that that's a robust way to go about answering the questions. And I'll also tell you one other thing. So it's rare, but occasionally I get students that will have, Ignithium, and instead of being just off by a penny, they'll be off by, let's say, 5 pennies, like 5 cents, and it won't score them correctly. And I don't either, so you got to be careful about that. But if you're really, really close, I want you guys to know. And so really, really close means like instead of 1 pennies, maybe it's 2 pennies, right? So like really, really close. And Ignithium scores you wrong, then don't worry too much if it's really, really close, because what I do, you won't see it on the scoring that's available to you, but when I download the data at the end, I widen that band just a tiny bit. So there's less of a chance that anybody gets screened out for, ridiculous rounding error. But that's just a, it's not a promise. It's not an absolute, guarantee. The precision is what is required. But I want to let you guys know that I do that just because I understand if it's really, really close, that, rounding error may be an issue. But, if it's off more than a tiny bit, then even with the correction I do won't help you. So, all right. So here's another one. This is question number 7. So we're halfway through. We only have to question 14. And so consider the following system of equations, blah, blah. At what value of y do the lines cross? Who wants to volunteer for that one? Okay, I'm looking for volunteers. Okay, Dawn, you volunteered again. Okay, so you get your mic?
Yeah.
Okay, so just tell me graphically what I should do.
Where they cross.
Okay, so I should go to where the red line hits the blue one, right?
Yeah, yeah.
And I want to point out to you guys, again, I can kill um, the blue and the red line. The crossing point of the lines, because sometimes, right, you can see there's like so much data, it's difficult. Like, am I exactly on the green one? If I hit it just right, um, we could probably see, but there are a lot of points like right around there. Oh, there it is. Can you guys see the little green border? And it says equilibrium, right? So where they cross is what we call the equilibrium in most of our examples in this class. But if you guys ever get like, I can't really see, exactly where the green one is, it's too hard because it's too small, I blew up my screen or whatever, then just do that and the green one will be left all by itself. And so what answer should we put in there then, Dawn?
51.8.
Yeah. So it asked for the value of y, which is the price, which is $51.80. And if I submit that, then I get this calculation. Now, again, I would tell you guys, and you guys can get your calculator out and you could plug it in your little machine, and maybe we should take a moment to do that. I just need to go get my phone for a minute, and then I'll show you guys my calculation. Mm. So it says 83 minus 3 times, and then I have a couple of parentheses here, 83 minus 31 divided by 3 plus 2, and can you guys see? Okay. Everybody see what I did? So yeah. So and honestly, there are different feedback options available on Ignithium, and you guys might ask why I chose this one. Well, I chose it because I just thought, like if I was a student and I was trying to think my way through this stuff, even though I know I can look at the graphs and I'm just looking at the crossing point, and if I choose it carefully, I can get the right answer. That's all I have to do. If for whatever reason I happen to choose the wrong answer, I would be curious. Well, where did they get that from? Where's that number? How is it related to anything that's in the problem? Because if you just get a number as a feedback, then you don't know. It's just a black box. You don't know where it came from. Now you can go back and you can look through lecture notes and you could do other things like that and try to figure it out. But I chose this option because I wanted you guys to be able to see that there's an underlying calculation. And if you guys were actually going to go on to do more advanced economics, then you would learn, the substance of the calculations that are in the background. Right now, like I said, we're just interested in picking labels off of graphs. So it's not supposed to be necessary for you guys to understand where this solution comes from, but it's there. So if you ever have any questions, I can always explain it to you guys if you guys are ever really curious, because it normally relates to something in the problem. In this case, here is the value of x where the two lines cross, and it's just taking that x value and it's substituting it into this first equation to get the y value that corresponds to it. So it's picking that 10.4 units and it's plugging it in to equation 1 and getting the y value that's associated with it. So that's where the calculation comes from. But in lots of other cases, we'll see later on, you know, it corresponds to something else. So, but you know, something that's easily interpretable. When the equations get kind of long and messy, it gets a little bit more difficult. But yeah, and yeah, Yasmin, I do have the lecture being recorded right now. And so this one's really easy. Yasmin, do you have your mic on since you were asking a question?
Hi, yes.
Okay, so what about this one? You want to answer this one for us?
Well, I'm kind of confused with everything, but that's why I wanted to know if it was recorded so that I can go back and
Well,
rewatch it.
let's just read it. You want to read it or you want me to read it? We'll walk through it. So it says, consider the following system of equations. You got equation 1, which is this one, and equation 2, which is that one. They're in the order they appear in the problem. So that's equation 1, and that's equation 2, the graphs from. And it says, at what value of x do the lines cross? So where do you think I would look here?
In the middle.
Yeah, in the middle. That's where they cross, right? And can you see that point where they cross? I don't know if you can see. There's a little green border, but we call it the equilibrium point. And then it's just asking for the value of x. Can you tell what's the value of x there?
I'm not sure.
Okay, well, what's on the x-axis? Do you see a label down there? So remember the x-axis is the horizontal axis. You see this label?
Yes.
Yeah, right? So there are two numbers there. It's actually an XY pair because that's normally the way that we write XY. I don't know if you remember, like, again, like from you know, you'd have an XY pair. And in this case, the pair is, well, actually, I can get rid of this and this so we can isolate it because it's always going to show up, like I said, is, what did it say, 7.6 and 56.4. 56.4. Does that help? Does that make sense?
Yes, it does. Thank you.
Yeah, and so then that's just plotted there. So what should we put in here? Our x value is
7.
yeah, 7.6. Good job. So and again, we end up with this thing, right? But do you have your calculator? You have your phone?
Yes.
Okay, you want to put that in your phone and see what you come up with? Drum roll. Because
It comes out to 7.6.
yeah, then the crowd goes wild. Okay, Yasmin, thank you. So good job. So yeah, these are the calculations that are being performed to verify whatever answer is here. So anyway, you don't have to, again, know why it's being calculated this way. It's not part of the class. But if you're curious, you're like, where do they get this from? Then you can see. And also, I mean, not like I'm suggesting you guys do this, but it's just, like for your own personal, um, feelings of confidence in the answers. You can see that the calculations are related to, the algebraic descriptions of these graphs for what it's worth. But you don't need to know any of that. All you have to do is say where the lines cross. You pick out the green dot. You say, oh, on the x dimension we've got quantity. The y dimension we've got price. They're asking for the x value, and it's 7.6. You get the right answer. Move on to the next question. Okay. So when we get together next Tuesday, we still have probably 4 more questions to go through. And then, this will be officially assigned. In the meantime, you can go on Ignitium, you can practice on your own, and I'll go ahead and